When you experience an eclipse, you feel that connection with space.
Oh my gosh!
Oh, look at the ray structure!
The universe is out there and it's affecting us. We are in space.
And here it comes, there's the diamond ring. And that is the most spectacular sight.
If you haven't seen it, you haven't seen anything.
Hello, everyone. I'm Acting NASA Press Secretary Faith Mackey, and thank you for joining us this morning as we look forward to the upcoming total solar eclipse on April 8th. During today's press conference, you'll learn more about what to expect during the eclipse, how you can participate, how NASA and government agencies will use the eclipse to advance science, and how to view it safely. Today's participants include NASA Administrator Bill Nelson, NASA Deputy Administrator Pam Melroy, NASA Associate Administrator Jim Free, Director of NOAA's Office of Space Weather Observations Elsayed Talaat, and NASA Eclipse Program Manager Kelly Korreck. After remarks from each of our participants, we will gladly take questions from the media. Now I'll hand it over to Administrator Nelson to kick us off.
Good morning. Before we get started, we were supposed to have the Federal Highway Administrator, Shailene Batt, with us this morning. You've probably seen the emergency that's happening in Baltimore. Our thoughts are certainly with them. Our prayers are with the people and the families involved. I've often said that at NASA, our mission is for all humanity, and that's because space brings us together. There's no better proof than moments like this, a total solar eclipse. It's a moment when millions of people across North America will look to the heavens as the moon passes in front and between the sun and the earth. And it's a rare sight that we haven't seen in 7 years. And unusual things start to happen as the normal rhythms of Earth are disrupted. When you're seeing this eclipse, you ought to observe this. As the day appears to turn to dusk and then dark, people have heard birds stop singing. They've seen giraffes suddenly begin to gallop. Roosters start crowing and crickets chirp. So watch for these unusual behaviors. And we encourage you to help NASA observe the sights and sounds around you. Eclipses have a special power. They move people to feel a kind of reverence for the beauty of our universe. Their power is not only to unify us on Earth, but to further science and discovery. In 1919, Albert Einstein's theory of gravitational bending was proven when scientists measured how stars shift when the sun is blocked out by the moon. And today, over a century later, a total solar eclipse still brings great opportunity in science. Pam is going to share a little bit more about how NASA missions will use this rare moment to advance science. Safety is always NASA's #1 priority, and that remains true for this solar eclipse. Make sure you have the proper eye protection, like the Eclipse glasses. And as you look at the heavens on April the 8th, when the eclipse starts, please, please put those glasses on. Now, I'm going to hand it over to Pam.
Thank you, sir. Yeah, this is such an awe-inspiring moment. I remember the first time that I learned that this is, it's kind of a very rare thing, that it just so happens that our moon is at the right size and distance to cause this effect here on Earth. And I hope that the awe that you were talking about, sir, is completely, understood by everybody who gets to experience it, because it's really a miracle of our universe. Of course, we're super excited. I mean, we are incredibly excited and have been building up to this moment, anticipating the solar eclipse and the incredible scientific opportunities, which it's my joy to talk to you about today. At NASA, we explore the unknown in air and space, and so we're always looking at pushing that cutting edge of science. We really want to learn more about the universe and our place in it. The thing that's so unique about a solar eclipse is that it's an opportunity to look at three celestial bodies: the Earth, the moon, and the sun, in entirely different ways than we usually do. And our scientists are going to take full advantage of this celestial event to get invaluable data. One focal point is definitely the sun's atmosphere, or the corona. So this is a very elusive region, and it can be viewed during a solar eclipse in a very special way. It's key to understanding fundamental questions about how heat and energy are transferred out into the solar wind, which contributes to our understanding not just of solar dynamics, but also how solar flares and the solar wind will affect life here on Earth. Things are happening with the corona that we don't fully understand, and the eclipse gives us a unique opportunity to collect data that may give insights into the future of our star. And it just so happens we're at solar maximum, so the chance we're going to see something amazing is very high. We're also leveraging this unique opportunity to look at the effect of the sun on the Earth's atmosphere, particularly the ionosphere. That's the electrically charged part of our atmosphere that can act as a conduit for many of our communications and navigation signals. So understanding how solar energy affects the ionosphere is crucial for predicting and mitigating potential disruptions to our technology. By observing the temporary decrease in sunlight at a much quicker time scale than we experience for sunrise and sunset, we're going to gain insight specifically into how sunlight affects the ionosphere. But as I mentioned, there are three bodies involved to make this eclipse happen, and thanks to highly precise mapping of the moon from our Lunar Reconnaissance Orbiter, we can actually unlock new knowledge during an eclipse. Studying the moon's silhouette against the sun lets us learn more about the sun itself, allowing us to study solar active regions such as the chromosphere, very hard to see with a traditional coronagraph. We're also going to make use of the moon's terrain to study the sun's shape and size. And our detailed knowledge of the moon also allows scientists to predict the shape of the moon's shadow on Earth better than ever before. So in essence, we are thrilled about this opportunity to conduct amazing, valuable science during the eclipse, and we want everyone to join us in this exciting opportunity. Thank you.
Thank you and good morning. We're just a few days away from witnessing a cosmic masterpiece, where NOAA's satellites will provide the nation and the world with a front row seat to the celestial wonder. The Solar Ultraviolet Imagers, or SUVI, aboard NOAA's GOES-16 and GOES-18 satellites will capture the moon's disk as it passes in front of the sun. and the advanced baseline imagers on these satellites will track the moon's shadow as it moves across the path of totality. The video here shows the moon's shadow from the annular eclipse in October. NOAA and its partners at the North Carolina Institute of Climate Studies also provided this interactive map which shows the climatological percentage of clear sky during the eclipse at all these different locations to help people plan their viewing experience. Once the eclipse is over, NOAA and NASA will continue preparing for the upcoming launch of the GOES-U satellite, scheduled for June 25th. It will carry the nation's first operational coronagraph, which is a solar telescope that blocks the disk of the sun. With this powerful instrument, we will see the fainter outer atmosphere of the sun, called a corona, where extreme space weather events originate. An additional coronagraph will be on the Swiffle-Lagrange 1, also known as Swiffle-L1, observatory, which is scheduled to launch next year in 2025. This NOAA satellite will be stationed 1 million miles from Earth and positioned toward the sun, where it will act as an upstream buoy, capturing data from incoming space weather events. Both of these coronagraphs will give us an unprecedented view of the sun. But what you may not know is that in a total eclipse, we see the corona in a way that not even coronagraphs can fully capture. This is why we call it nature's coronagraph. We look forward to getting this unique inside look from nature on the types of measurements we need on a continuous basis for space weather forecasts and warnings. Thank you.
Thank you, Elsayed. Good morning. My name is Kelly Korreck, and I am the NASA Eclipse Program Manager, excited to discuss the ways NASA is using the solar eclipse for scientific discovery. In addition to our over 20 satellites in NASA's Heliophysics System Observatory that regularly observe the sun, we'll be using rockets, planes, and balloons, and on-the-ground observations to optimize the science return of the eclipse. As the previous speakers mentioned, the sun and its effect on the Earth, called space weather, is one of the motivating factors in our study of the sun. And although the focus will be on our sun's corona, or outer hot atmosphere, as the moon blocks the bright disk of the sun, the eclipse also gives us the unique opportunity to research our Earth's reaction to that sudden loss of sunshine. So starting with our Eclipse rocket experiment, APAP is a series of 3 rockets launched from Wallops Flight Facility to explore the layers of the Earth's atmosphere called the ionosphere. So again, that layer is important as it's the one that our communication signals pass through. Disturbances in this layer can cause issues with GPS and communications. The series of rockets will sample the layer of the atmosphere to see how it changes with that sudden day-night change of the eclipse, and that information can be fed into models for us to better understand the Earth's atmosphere. NASA's WB-57 plane, with 2 solar experiments and 1 atmospheric experiment aboard, will chase the eclipse, getting an additional 2 minutes of totality and deeper understanding of the sun and the Earth's atmosphere. So dozens of student teams will launch balloons along the eclipse path before, during, and after the eclipse to get measurements of the Earth's atmosphere. In addition, a NASA team will be using a balloon to study the weather of the eclipse. Now, citizen science is a way for everyone to join the NASA science exploration during the eclipse. I'm highlighting just 3 of the over 40 projects that folks can participate in. The first project is SunSketcher. It utilizes a smartphone to help understand the size and the shape of the sun better. The second project is focused on the reaction of our atmosphere to the eclipse. It's called Globe Observer. This app has you record things like temperature to understand the effect of the eclipse on the atmosphere and clouds. The third project is Eclipse Soundscapes, that you will explore the reaction of wildlife on the eclipse and the sounds that you'll experience during it. So these are just a few of the ways to engage with the eclipse and NASA science. The eclipse is not just a stunning visual experience, and I hope you will join us in these discoveries. Thank you.
Now we'll hear from NASA Associate Administrator Jim Free about how NASA is bringing the excitement of the solar eclipse to you with a few safety reminders.
Thanks, Faith. Well, I don't know about you, but I remember where I was during the last total solar eclipse, and I'm really excited about this one, and I didn't even understand all the science. Nikki Fox will probably hold me accountable for that. So I'm sorry, I think the wrong remarks are up. Thank you so much for joining us here today. I appreciate the opportunity to kind of share with you some of the things to be safe about, and I join the administrator in the condolences to everyone affected. You know, during the eclipse, we want to make sure that we're not relying on our standard lights on our cars. We want to make sure that we're looking out for the pedestrians. Please don't just stop on the side of the road. It's really important to make sure that we stay focused on everyone around us. People are probably going to be stopping, so be careful. You know, I want to make sure also that we highlight the importance of the science that everyone can be inspired by the eclipse. It's important to look at all the science we do at NASA. I think when we look to the heavens, we're inspired. Everyone's going to be looking to the heavens with their glasses on, in this case. But when you think about the power of the sun, what we're doing with other celestial bodies, where we're blocking out the sun with coronagraphs in the future to look at the habitable worlds around those, that's the inspiration that we can all take away from this. So I'll remind you of the safety of what we're doing, the safety of what you need to be doing, looking only with your glasses, the safety of what you're doing while you're driving, and then also what you need to remember about the inspiration that we can all take away from this eclipse. With that, let me turn it back over to Faith.
Thank you all so much. Well, that brings us to the Q&A portion of today's press conference. We do have a few media here with us in the room, as well as the phone lines. I do ask that you please focus your questions specifically to the solar eclipse and identify to whom your question is directed. I'll start first to see if any media in the room have a question before we kick it over to the phone lines. And if so, we have some mics here in the room for you.
Hi there, Karina Capabianco with Spectrum News. Just a question for the administrator. Can you speak a little bit about how NASA's technology has changed since the last solar eclipse?
Well, I'll give you one very good example. In 2018, we launched the Parker Solar Probe. In addition to everything that we are going to learn from this experience in a week and a half when the moon moves in front of the sun, shortly thereafter, the Parker Solar Probe is going to go in and touch the sun. Interestingly, it's not going to touch the surface of the sun, although it's hard to determine what is the surface since there's no hard surface. It's going to touch the hottest part, which is outside of the sun, sometimes at 1,000,000 degrees. And hopefully it's going to be positioned exactly right with its heat shield so that the heat shield is going to keep it at a relatively warm 87 degrees in its temperature while it is absolutely cooking on the outside of that heat shield. And we're going to measure all kinds of new things that we've never known before because of the Parker Solar Probe. So the technology has rapidly advanced, and we're going to be the beneficiaries of that.
Thank you for your question. I think we'll kick over to one of the questions on the phone. We have Brett Tingley from space.com.
Hi, thank you very much for taking my question. This is for anyone at NASA. I'm wondering, will there be any plans for the crew aboard the space station? Will they be able to watch the eclipse, or is anything planned for them on Eclipse Day? Thank you.
Yes, they will be able to see the eclipse, but with a very unique vantage point. So instead of looking up at the moon casting the shadow, they'll also be able to see the shadow racing across the Earth. So there is involvement, and they will be able to participate in that way.
Great.
Thank you.
Next question, we have Jim Siegel from NASA Tech.
Hi, everybody. Thanks for taking my question. And this is an exciting event, so thank you for briefing us this morning. I think this is a question either for Pam or for Kelly. Could you talk a little bit about how NASA predicts the path of the eclipse ahead of time? In this case, diagonally across North America. How is that done exactly?
This is a great question, and we have our scientists who work on this to predict these paths. So these paths have been known for a while, and they come in kind of cycles that are mathematically able to tell when we're going to pass the moon in between the Earth and the sun just right, so you get that shadow cast. And based on the orientation of the sun, the moon, and the Earth, and taking into account all the different tilts of everything, we're able to make those band predictions. And then NASA used the LRO, as Pam referenced, the Lunar Reconnaissance Orbiter, and the data that was studied there to make that map even more precise, because we now know the exact peaks and valleys on the moon, and we're able to tell you just how far that shadow of the eclipse will project onto the Earth.
Thanks, Kelly. Now we have Alan Boyle on the phone from GeekWire.
Thank you. I guess this question is for Kelly, and it would relate to webcasts of the eclipse. Can you provide any more details on where those web views will be coming from? Any other activities, for example, live activities? Is there kind of a base of operations for what NASA is doing in the path of the eclipse? Thank you.
Thank you. Yes, there will be a live NASA broadcast from 1 to 4 on Eclipse Day. That'll be on NASA Plus and several other outlets. We will have telescope feeds as well as experts talking about the science of the eclipse and other science that NASA does with the sun, as well as our exploration. We will be located in 13 different sunspots. So a sunspot on the sun is a place of intense magnetic activity. And so we're going to have some intense activity around eclipses in these sunspots along the path. And so those 13 spots are spread out to also give us a difference view. So we have folks such as the Dallas Arboretum, or a partnership with NOAA and the National Science Foundation at the Dallas Cotton Bowl. We are also going to places like national parks in Little Rock, Arkansas, or Hot Springs, Arkansas. We will be in Russellville, Arkansas. Cleveland, where NASA Glenn is, will be also one of those hotspots and the anchors of the broadcast. And the other anchor of the broadcast will be in Kerrville, Texas, at a river festival outside, where I think a few of us will be attending as well.
Thank you. Well, that's all the questions that we have on the phone. Want to do one more last check for any questions in the room? All right, well, that's all the time that we have for today. Thank you so much for joining us. To learn more about the eclipse, please visit go.nasa.gov/eclipse2024. And no matter where you're on April 8th, whether it's one of our sunspots or online, we'll hope you join in the fun and, of course, the science. And please don't forget to wear your glasses. Thanks so much and have a great day.
Today's conference, you may now disconnect at this time. Have a wonderful day.